Hello, hello.
Good morning. Here we go. We are live on Twitch as well, which is great.
Awesome. Hi, Jonathan.
Hello, hello, hello. Lorenzo, how are you doing?
Good, good. Ready for this live coding session. Excited to be part of this functional February.
No, it's gonna be awesome. So thank you for taking the time and prepping everything and getting yourself going. So where are you currently based at the moment?
I'm based in London, in the UK.
Awesome. I'm currently sitting in Switzerland. My wife's family are from here, and but normally we're in Cape Town, so it's nice to be a little bit closer than 9,000 kilometers away.
Indeed.
But do you want to just maybe introduce yourself a little bit and what you'll be looking at today? I'll just go first quickly. I'm Jonathan. I'm the community manager at Exercism, and I'm kind of helping facilitate some live streamings in our 12 and 23 initiative, which is all about learning 12 languages in the 2023. And this month we're looking at functional languages. So that includes like Scala, Gleam, Elixir, a whole host of others. So if that is an area of interest and you're watching this, then do check out exercism.org. But today, Lorenzo, why don't you introduce yourself and let us know what you're getting up to today?
Yeah. So a few things in the IT world. I come from a background in software engineering in various languages, mostly Java, Scala, a bit of JavaScript. And then over the last few years, I've been working in management positions. But for all intents and purposes of today and over the last few weeks, I've been live coding a bit and doing what we call public learning. So learning in the company of viewers on Twitch or YouTube or whatever other platform. Just with the idea of showing what goes on in the process of figuring things out. And so getting stuck is usually part of that process. But that's all, meant to help people understand what goes on behind all the nice and pretty code we write as software engineers.
Great. Oh, nice one. So do you want to just share a little bit about what your specific exercises that you'd like to walk through today and then how maybe people can get involved as you're going and asking questions?
Yeah, absolutely. So today we thought we'd do a bit of coding in Scala and a bit of coding in Elixir. They are two good languages to represent functional February. We can also maybe draw some comparisons between the two. I had initially thought about a couple of exercises, but we'll see where we get to, and I'll try to highlight as we go through the functional aspects of the solutions we are implementing. And we'll start with an exercise in Scala around the Hamming distance, which is something that measures the distance between two strings. And then we'll see where we go with Elixir. The first part of the live stream is going to be a bit more structured. And the second part is going to be more about let's figure things out together. So if you are an Elixir coder or developer, I could use your help in the second part of the session, definitely.
Cool. Perfect. That's great. I'm on the chat as well. So Lorenzo, you can focus on the coding. Aguilar, welcome. Good to have you here. We're going to be recording these sessions, and then we can you'll be able to access the sessions on Twitch. So we've enabled now that any broadcast will be recorded and will be kept on Twitch for a time being. I think it's 2 weeks. After that, we'll look to post these on our YouTube channel as well. But Lorenzo, if you have a YouTube channel as well, you can find. I'm sure we'll be able to have the video across YouTube on his channel as well. I think if you have one, hey Lorenzo, do you have a YouTube channel yourself?
Yeah, I do. You can just look up my full name, or just look for El Barasti up here, and then you'll find me both on Twitter and YouTube and Twitch, all the platforms.
Great. Yeah, just so you all know, we're in the process of working out how to best distribute the content that we're putting together, but it will be on Exercism as well, so you can check that out there
and
as well.
Jonathan, you mentioned the fact that we were looking for we were looking to cover different ranges in terms of time and time zones as well. When I selected this time zone, I was thinking about the fact that, yes, this is Central Europe friendly, so to speak, although it's a bit early, maybe some people are working, but this is usually an Asia friendly sort of time zone choice. in the sense that for people in Asia, this should be evening or late afternoon. And so a good time to tune in on Twitch.
Cool. Awesome. Nice one. Well, without further ado, Lorenzo, I'll hand over to you. Take it away.
Thanks. Yeah, thank you. Okay, so as you know, we are dealing with exercises in the context of 12 in 23 and the 12 in 23 challenge that Exercism launched a few weeks ago. And the idea here is to go through a number of programming languages and learn as much as you can. I've already done my part, and so I've done my 12 languages for 2023. But the great thing about that is that now I can go a bit more in depth with each one of them. And since we are dedicating February to functional languages, today we're going to be doing some exercises with Scala and with Elixir. So what I'll do is I'll show you the introduction to one of the exercises for Scala, which is called the hamming exercise. And then we'll go into the editor and we'll write some code together. And I will try and highlight the aspects of the solutions that make this suited for a functional language such as Scala. Looking at the instructions for the assignment, the idea, as I mentioned earlier, is to, in a way, compute the distance between two strings. And so you'll have a sequence of character and then another sequence of character. In this case, these two sequences represent DNA sequences, and each character represents a so-called nucleotide. But that's just a particular example. But what we care about is whatever two strings we have, we can compute the distance between the two in some useful way. And this would even work were we to compare bit strings, if that's something that maybe you're thinking about. And the idea is to just count the number of instances where the corresponding characters in the two strings are different. So in the example given here, you can see there's 1, 2, 3, 4, 5, 6, 7 differences when comparing characters pairwise. And so the hamming distance between these two strings is going to be 7. I have one idea about how to go about solving this exercise, and I'll show you what my first intuition for figuring this out was, and then we can iterate a bit and try and stress some of the aspects of functional programming. For example, and you'll be able to also watch a video from Exercism where I think Jonathan helped me out here. I think Eric and the other Exercism founder talk about functional languages. And that's actually a great introduction because they go and talk about functions as first-class citizen, the concept of pure functions, immutability, pattern matching, and recursion. I think today is going to be a very pattern matching heavy session from some point onward, and we'll do a bit of recursion as well.
Yeah, cool. I'll paste the link to that video in the chat so people can access that.
That was brilliant. Thanks, Jonathan.
Okay, perfect.
Okay, so the first idea here that comes to mind is, so we're looking at some Scala code, and we have the definition of an object, which is just, you can think of it as a wrapper for a bunch of functions and methods. And so you can think of it as a module in other languages. Likely that's what you would be calling that in Ruby or maybe in Elixir, for example. And we're just defining a function called distance. It takes two arguments, both of type string, and it returns an option of int. Now, not everyone might be familiar with option as a type. The idea with option type is that they represent a potential absence of value. So this will be something that might come in handy when you're, for example, considering a function whose result is defined on a number of potential arguments, but not on another set. For example, take the square root, for example, which we're all familiar with. If you try and compute the square root of a negative number of a negative integer, for example, you might want to just return some sort of error, or maybe just say, I can't compute this value because this operation is not defined on negative values. And option gives us the ability to, rather than explode with an error in the user's face, we can just return a none, and none represents the absence of a value for the operation. In this context, because we're computing the distance between two strings, we're making one assumption, which is that the two strings are of the same length. Hence, if the two strings are not of the same length, we will be returning none. And we can actually start exactly from that place, right? And say if DNA strand 1 dot length or size is not the same as DNA strand 2 dot size, then throw an exception. Or that would be an approach, right, in another language. But here, given that we have options, we can just say return none. And if we do this and we try and run this, and I'll give a bit more space to test here. We should fail a bunch of tests, but also we should maybe pass some, making sure that we spell things properly. We are returning unit as opposed, just making sure that we are returning something. I'll just return sum of 1 if the first test doesn't succeed. And let me also be explicit about returning, because when you're defining the body of a function, you have to explicitly return a value. Otherwise, the compiler will complain, oh yeah, actually, we should be okay. And so what you can see is that we passed the set of tests. And in particular, we passed all the tests where the two strings provided were not of the same length, right? So complete distance in single nucleated strands, small distance is more, we're just also hitting a few tests where we are returning 1 and we are just guessing, right? But for example, when we say this allows second strand longer, which we can go and look more in detail, I'll check for longer. For example, Hamming distance, AATG and AAA, the distance cannot be computed because the two strings are different lengths, and so we expect none as a result. We are passing that test now because we are checking appropriately that the size of the two strings is the same. Now we just need to figure out what happens when the two strings are the same length. And one approach that comes to mind, which is quite declarative in the way we describe it, is to take the two strings, look at characters pairwise and compare each one of them. And if they are the same, then we just don't count that. If they are different, then we count 1 and then we sum all the values together. And in Scala, there's a very simple way of doing that. First thing we'll do is we'll zip the two strings together. And the idea with zipping is that we go from an array of characters, which is a way of thinking about a string, to an array of tuple or of pairs of characters where you have the ability to compare characters pairwise. That would be something like DNA strand 1, zip DNA strand 2, something like this. And then now that we have, and the type of this thing would be an array of, or maybe in Scala that would be a list of tuples and of pairs in particular. So a list of string. This would be the type of the expression. Okay, I'll just put it in a comment here. And if we want, we can actually assign it to a value and say zipped equal this, and we can do it for didactic purposes. We don't really usually define a val for this small operations. Once we have zipped, we can iterate over zip. There are a few ways of doing that. One way would be to do for each, but the reality is the Scala language actually offers more convenient utility methods here, and so we can actually just count directly, which should make our experience even smoother. And in particular, what we want to count is we want to count the scenario where the two characters are different. So how do we go about doing that? We can count, we can take our left and our right characters, and then we can return 1 if L and R are different. And I need to wrap this in parentheses. So if the two are different, then we return 1, we count 1. Or actually, we just say, if these are different, it should be even easier than this, right? We can just say if L is different than R, then just count it. And if I just try and run the tests, I know this might look like magic, but this should just work. And just making sure that we got all the spelling right. And I'm also checking that I got the parentheses right. Okay, do I need to be explicit about? No, I think this is fine. It's saying on line 4, expecting on the zipping. Okay, so there's something wrong here, right? Let me just check this again. Ooh, and we might also have to be explicit about returning sum of something, right? So let's go back to this, make sure the compiler doesn't get confused. And also I need to make sure that my type declaration actually works. Let me try and remove this. Let's see if this makes the compiler happy. Maybe a bit better, yeah? Yeah. So I don't know what about my type was confusing the compiler, but I probably got something wrong in the process. But yeah, we don't need to be explicit about that. We can let the compiler infer that, but that's going to return a list of tuples. And then once we are done, we can, again, count the number of instances where the characters are different and then return that number, right? And so again, I'll just define a variable here, call it count, and just return sum of count. And this should actually get us to a place where we are all green and we're passing all the tests. Here we go. Here we go. So this works. We defined a few too many variables and maybe we didn't need to, but it's good to just keep track of what's going on here, right? And if you look at this, we could probably just make this a bit more concise. And usually if you're looking at some actual Scala code, you will probably look at someone just returning a value count here all in one go, where they go DNA strand 1, zip DNA strand 2, and then they will concatenate the count function straight up like this. So that's probably what you're going to be seeing in regular Scala code bases. We'll go one step further here, and we'll try and make this a bit more exciting, because one of the features of that you usually find in functional languages is the fact that functions are treated as first-class citizens. And so I wanted us to do an experiment and try and extract this anonymous function that you see in this block here into its own variable, and then pass that to the count function as opposed to just inlining, putting everything on the same line. And again, this is a good example of what it means to have functions as first-class citizens. It means you can basically define functions the same way you define any other value, and then pass them around as arguments to other method calls, for example. So we'll do just exactly that, right? So we'll still check if the DNA sizes are the same, and then we'll just define somewhere, and it might even be a val within the body of this function, just for the sake of demonstrating this, and we'll call it countDiff. And countDiff is an actual function. How do we go about defining this? Well, we want to define this as a function that takes a pair of characters and returns a Boolean value. Okay, and we can just copy paste this, I think. Let's see if this just works out of the box. Let's say define countDiff as a function that takes 2 characters and returns a Boolean. And then I can just pass this into the count function like this. And you can see now it could all go into a single line, and I can run the tests. And what is nice about this approach is that, as you can see, we are treating count diff just as any value. You can just pass it around. You can also imagine how easy it is to actually test this function in isolation. So we can actually verify that our logic is working as expected somewhere else, and then use it and reuse this function anytime we need it. You can also see how we are encapsulating the logic for the count somewhere separate from the actual DNA string comparison. And this means that if it ever becomes the case that we want to change the condition here, we know where we need to go. We need to go to the count diff function. We can maybe change our mind and say, well, from now on, I want to count the number of characters that are the same rather than the ones that are different. Or, for example, if the character L is A, then use a different criteria. We can all do that. We can do all of that in the count diff function. So this is a first good trial in solving this exercise, where we have used some of the features of functional languages. I would say a couple of things in particular. The fact that we're returning an option rather than throwing an exception when the arguments are not the right size. That's something that you will see in a lot of languages. It doesn't matter if you're using Haskell or Elixir or Scala. And then the other aspect, the fact that we can define functions as values and then pass them around into functions. We've seen that as well. And then you notice another thing, which is this very declarative way of transforming data. And so going through steps, which is something that Elixir is very popular for, but Scala offers loads of utilities on collections to do exactly the same thing. And so you go from DNA strand 1 to the pairs of characters, and then you count, and it all looks like do this, do that, like you're zipping and then you're counting. And we don't even have to worry about how that actually runs in the background. We're just letting the program know what needs to happen. Okay, how are you feeling about this, Jonathan? How are we doing?
This is great. I mean, I'm just learning some cool stuff here, and just watching the chat, and yeah, it seems like you're doing a great job just explaining. So awesome. Keep it up.
Good. So what I wanted to do before we move on to some code in Elixir is to try and rethink the solution and think about whether there's ways of rewriting this in a recursive fashion. And again, we're only doing this because it's a good exercise. It's not that the recursive solution is better necessarily than the non-recursive one, but it's also a way of looking at how functional languages sometimes do with the absence of variables, because in some functional languages you don't do destructive assignment on your variables, and that's why you usually talk about bindings rather than variable assignment. And so recursion is one of the mechanisms that allow us to write programs that do something without having to use destructive assignment, which is when we assign new values to the same variable. The other thing we'll take the opportunity to do as we rewrite this in a recursive fashion is we'll look a bit more extensively into pattern matching, because that's, again, one of the things that make functional languages so much fun to work with. Okay, so how do we go about thinking about a recursive solution for this problem? Well, the idea here is anytime you can think of a problem in a way where you can see that you're answering the question in a way where you could break the problem down into sub-problems, that's a good application of a recursive solution. In this case, for example, we are comparing two strings of characters, and it's not hard to think about the fact that if I tell you that the first characters pairwise in the string are the same, then in order to answer the question of what the total Hamming distance is between the two strings, the next step would be to compute the Hamming string of the remaining characters, right? And so we can think of the problem as breaking down the big problem, two long strings, into some smaller subproblems where you consider the difference between the first two characters and then compute the Hamming distance on the remainder of the strings. And what you know for sure is that because the strings are of finite length, we will get to a point where we have an empty string. And then at that point, we know that we can return 0 for Hamming distance of two strings that are empty. Or, for example, if we are left with a single character on the two strings, we know that the Hamming distance will be 1 if the characters are different, or 0 if they are the same. And we can just sum up all the distances that we've found so far. And that would be a way of thinking about this problem in a recursive fashion. The other thing, again, because we want to try and do a bit of play a bit with pattern matching, is we'll try and replace this first if, again, more for didactic purposes rather than because it's much better, and say what would this look like? So and try and compare cases depending on whether the sizes are the same or not. So the idea would be to start from our DNA strand 1 and 2. DNA strand 2, and then match these two strings. And all this code we will not need anymore. I'll just keep it here for the time being. And then what we'll do is we'll say, okay, in the case where the two DNA strands are the same length, then do something. Otherwise, just return none, right? And we can make this very, very clear. We can say case we have our string or our left, let's call it 1 and 2. These are still our string in case 1 size equals 2 size. Then we'll return something. We'll return the count of characters that are different. Otherwise, if we end up in the second clause of the guard, or in the second clause of the pattern matching, then it means that the two strings are not the same size because this condition failed, yeah? And in that case, we just want to return none. And again, if I try and compile this and say just return sum minus 1, right? If the size is the same, otherwise return none. If I try and run this, we will still pass the tests where we are comparing strings of different size, but fail everything else. Just let me make sure I actually put an arrow here rather than equal, and then should be able to move on. Meanwhile, if you have questions, feel free to ask on the chat, and we'll try to answer them. Okay, as promised, we are passing the test where we only look at the difference in size and return none if the two strings are different sizes. Yeah. So what happens if the two strings are the exact same size? Okay, so something you'll often observe in recursive solution is the fact that you tend to rely on some sort of auxiliary function, meaning you have a main function that is the entry point to your recursive calls, and then you will find a call to a recursive version of that that in some way lets you accumulate the results, or at least lets you keep on computing until you hit some sort of base case. So in this case, you can imagine the recursive function will be called something like distance rec for distance recursive. And what we'll do is we'll say, well, look, let me go on a new line here. We'll say, first of all, we'll say, compute the distance between the first character. So we'll check whether the first character and the second character are the same. And then depending on that, or actually we can do all of that in the distance rec function. I'm just thinking for a moment. Yeah, we can just say distance rec 1 and 2. And then we can say start with a Hamming distance of 0. Do we need to do that? Maybe not. And then let's go and define distance rec as a private function or private method of the object. Getting there. We'll pass in just the first and the second parameter, which are both strings. And then the first thing we need to answer when looking at recursive definitions is what is the base case in this context? What does it mean to have hit the simplest possible problem when asked to compute the humming distance between two strings? And in this case, that would be the situation where both the strings are empty, right? And so we'll assume that the two strings are the same size, because that's a check that we've done up here. And so we can assume here that 1 and 2 are the same size. And what we can do is we can, again, go all in with the pattern matching and say, okay, take the first string and extract the head character. And we use head option because this allows us to not throw an exception if the string is empty, okay? And then we do the same with the second string. We say, take the head option of the second string, and then we'll match again the same way we've done up there. And what we know here is that if both the head options are none, I could just say the first one is none and the second one we don't care, because we know that we are making the assumption that they're the same size. Then what do? Then we want to return whatever count we've accumulated so far. And again, so I will need indeed some sort of count which keeps track of the current humming distance, yeah? So we'll just return count, nothing to add there. In the case instead where we have some head character for both, and again, pattern matching here makes it really easy for us to extract those values out of the option that is wrapping them. Then we'll take a slightly different, well, we know what to do, right? We know that we want to compare the two. So we want to check if L and R are the same. And if they are the same, then we want to increment our count. So we'll call it about increment. And we'll say this is equal L. Well, let's say if L is different than R, then return 1, otherwise return 0. And this is the increment we want to have here. And then we'll just call distance rec again. Distance rec again. And this time we'll call it on a smaller problem, right? So the first string will be now 1 tail, which is the remainder of the characters, and the second string will be 2 tail, while the count will just be count plus the increment that we computed here. And so at each step, when the string is not empty, we keep on reducing the size of the string, because we go from the string to the remainder of the string past the head, and then we keep on incrementing the count with count plus increment. I want to stop here for a moment, because what you can see here is that we are making this recursive call to distance rec, and I want to show you how the compiler complains about this. And I'll tell you why it's compiling. Yeah. Also, let me make sure there's no other issue here. So line 8, private def, 1 string, 2 string, and then count int. Yeah. No modifier, illegal start of statement. That's interesting. What have I done? Def. Is it maybe the private that is? Oh yeah. Well, let me try and remove the modifier and let's see. I also expect this to complain about the fact that we're calling distance rec with no third parameter. A bit better, yeah. Let's see. Found unit. Okay, so let me just do this here. We want to start with a count of 0. And then the other thing that I wanted to show you is the fact that when we define a recursive function, we have to be explicit about defining the return type. And in this case, we are returning an int, right? Which is the distance. Let's see if this gets us to a slightly more useful error here. Maybe almost line 25. Oh yeah, I might have some unopened curly brace that was ruining my compiler messages. Should be a bit better now. Let's see. This closes this. Right. Okay. Doing a bit better here. This is private. Okay. Sorry. Just some indentation and missing curly braces. Okay. This should be a bit better now. Still a bit weird indentation. We'll figure that out. And this goes here. And now the problem is type mismatch. Oh yeah, of course. Expected option of int found int. Yeah, that's my bad. So we actually want to return. Okay, here we can actually return the int as we promised and just wrap distance rec with sum. I think that's the right thing to do here. And I can make this a bit more obvious what's going on here. Run the tests again. And then we'll just look at this from the top. Okay, so we're passing our tests. Let's just try and recap so we can clarify any confusion here. So what we're doing here is this time around, we are looking at the two strings and then comparing them. If the size of the two strings is the same, then we kick in with recursive calls. Otherwise, we return none. Now, this is 100% equivalent to an if-else statement, and we're not getting massive value out of this. It's just for us to practice a bit with the pattern matching and to show you how you can use conditional clauses in each on each case of the pattern matching. Then once we get into the recursive function, we're calling distance rec. We're starting with a humming distance of 0, and then we start comparing our two strings character by character. We extract the head character of each, and then depending on whether we find anything, we either return the count we've computed so far, or we go and compare the first two characters and then run the same function on a smaller problem. So on a sub problem of the initial problem, which is compute the humming distance of the remaining strings and keep on incrementing the count we got to so far. I'll notice one more thing. We are, as you can see here, calling distance rec with initial value of 0, initial count of 0. We can often remove this and just make this a default argument for our function. So let's see. Almost there. There we go. So all good here. What else did I want to show you? Okay, and in terms of more pattern matching, as you can see, we are extracting the first characters and then checking whether they are sum of a character. And if so, pattern matching makes it very easy to extract those characters without having to write too much code. Yeah.
Lorenzo, just quickly jumping in, do you mind just making your code a little bit bigger?
Yeah, sure.
That'd be cool.
Is this okay? I want to...
Maybe one more, just because it's... there we go. That looks good.
Okay, maybe this is... Yeah, I think there's a bit of a delay. I think this was the... Is this okay?
Yeah, I think so. Okay. That should be good.
Cool. Okay, nice.
Perfect.
Okay.
Sounding great, by the way. Going well.
Sounds good. Okay, so we have our recursive solution. We've looked at a bit of pattern matching, a bit of recursion, and so I think we are ready to move on to the next exercise. Jonathan, what do you think?
Yeah, I think that sounds cool. That sounds great. Cool.
So now with this, I think we start a part of the stream, which is more about learning things together than about me writing some code. So also noticing that there's an interview scheduled with the creator of Elixir in 3 days' time, Jonathan, which I think you had something to do with.
Yep, that would be Jeremy. He seems to move and shake in these kind of circles, so that's that's cool.
Great stuff.
Yeah, that'll be great fun. That'll be really, really cool to watch.
So in preparation for that interview, it's good for people watching to actually know some Elixir to start with. And so what I was thinking is we can actually go to the Elixir track, which is, by the way, one of the most well-curated tracks on Exercism. It's got a massive syllabus with great exercises and explanations, so highly recommended. And then we can go to exercises. I don't have many exercises available.
Yeah. Hmm. Perfect. Hmm. Yeah, that looks good. You can go on for forever if you want, Lorenzo. I mean, that's fine. Yeah, no, that sounds cool. So this has been great. Mhm. 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 Yeah, I'm just going to jump on the camera because I think everything's coming to an end. But no, I think it's what's cool is that you're seeing a lot of different ways of solving the same problem and how you approach it. So I think that's what we were trying to aim at for the dig deeper and for the community solutions. I think the dig deeper piece is interesting as well because you're going to have a lot of the opportunity, and the goal is that we have a lot of videos about how different people approach the problem. And I think that's one of the skills that we are really keen to sort of hammer home at Exercism, is that there's no one way to do it. It's just how you think through the problem and doing it in the sort of most appropriate way is a key skill. So Lorenzo, that was fantastic. I was sitting here watching and learning a huge amount, dabbling my toes in different aspects of functional programming. So really, really appreciate it. And yeah, that was awesome. Mm. Yeah, exactly. Exactly. Awesome. Well, Lorenzo, I'll let you close the live stream from your side. I think if you just push stop, and then we can maybe just carry on the conversation and take things from there. But again, thanks everyone for joining us. Great to have you all here, and we'll keep you posted as to when we release this video. Go subscribe to Lorenzo's YouTube, which is at Barasti, and drop him a subscribe. I'm sure that would be much appreciated. And in the meantime, check you around. Bye.